Back in the late 1960s and early 1970s, NASA's Apollo missions stunned the world. Astronauts walked on the moon, left footprints in the lunar dust, and returned safely home. But after Apollo 17 in 1972, human exploration of the moon stopped. Budget cuts, shifting priorities, and the belief that we've already done it stalled progress. Fast forward to today, the Artemis program aims not just to revisit the moon, but to build a sustainable presence there, a gateway to Mars and beyond. Artemis also focuses on diversity and international cooperation. The program promises to send the first woman and the first person of color to the lunar surface. Artemis II, launched in late 2022, was the proof of concept. It sent the Orion spacecraft on a 25-day uncrewed mission around the moon, testing heat shields, navigation, and communications. The mission was a success, giving the green light for the next big step: sending astronauts. What is Artemis II? Artemis II is the first crewed flight of NASA's Orion spacecraft atop the Space Launch System, SLS, the most powerful rocket ever built. The mission won't land on the moon, but it will fly a crew around it and bring them back home safely. Think of it as a test drive, but around the moon. The planned duration is about 10 days, covering nearly 1.4 million miles of travel. During the mission, Orion will perform a lunar flyby, using the moon's gravity to swing it back toward Earth. This will take the crew farther from Earth than any human has traveled since Apollo. Meet the crew. One of the most exciting parts of Artemis II is its diverse, highly experienced crew. Reed Wiseman, NASA, mission commander, former U.S. Navy pilot, veteran of the ISS. Victor Glover, NASA, pilot, the first person of color assigned to a lunar mission, previously flew on SPA-CEX Crew 1. Christina Koch, NASA, mission specialist, holds the record for longest single spaceflight by a woman, part of the first all-female spacewalk. Jeremy Hansen, CSA, mission specialist, a Canadian astronaut and former fighter pilot, representing international partnership. This crew reflects a new generation of exploration, global, diverse, and focused on the future. The spacecraft, Orion and SLS. To understand the scale of Artemis II, it helps to look at the machines making it possible. SLS, Space Launch System, the most powerful rocket ever developed, surpassing even the Saturn V, generates 8.8 million pounds of thrust at liftoff. Designed to carry humans and heavy cargo beyond low Earth orbit. Orion spacecraft, built to sustain astronauts for deep space missions. Equipped with advanced life support, navigation, and radiation protection. Features the largest heat shield ever flown, critical for surviving re-entry from lunar speeds up to 25,000 miles per hour. Contains an ESA-built service module supplied by the European Space Agency, which provides power, propulsion, and thermal control. Artemis II will test every major system in real conditions with people on board. What will the crew do? Artemis II is not just a joyride, it's a full-scale test mission. The crew will evaluate life support systems under real flight conditions, practice manual and automated navigation, test communication between Orion and Earth over long distances, conduct experiments to measure radiation, cognitive performance, and human health in deep space. At its farthest point, the crew will be over 230,000 miles from Earth, experiencing deep space environments that no astronaut has faced in decades. Why not land yet? It might seem strange to send astronauts near the moon without landing, but it's strategic. NASA needs to make sure Orion and SLS work perfectly before attempting a lunar landing. Artemis II bridges the gap between uncrewed testing and full lunar surface missions. Once Artemis II is successful, NASA plans to launch Artemis III, which aims to land astronauts on the moon using SpaceX's Starship human landing system. Challenges and risks. Space is dangerous. Artemis II faces several major challenges. Radiation exposure beyond Earth's protective magnetosphere. Re-entry heat more intense than any re-entry since Apollo. Complex international hardware integration between NASA and ESA. tight schedules, and high costs, as delays have already pushed the mission to no earlier than late 2025. NASA has spent years testing every system, running simulations, and upgrading safety protocols. The success of Artemis II is critical before moving forward. Why this mission matters. Artemis II represents more than just a return to the moon. It's a message that human exploration is not over. The mission aims to build long-term infrastructure in lunar orbit and on the surface, prepare for moon bases and resource extraction, like mining water ice for fuel, serve as a launch pad for Mars missions, inspire a new generation of scientists, engineers, and explorers. For the first time, the moon becomes a stepping stone, not the finish line. The future, Artemis III and beyond. If Artemis II succeeds, the next chapter begins fast. Artemis III aims to land humans near the moon's south pole, a region rich in water ice, vital for future missions. Then comes Artemis IV, which will help build the Lunar Gateway, a small space station in lunar orbit. This gateway will act like a space airport for future travel. Eventually, NASA envisions permanent lunar habitats, regular flights, and international collaboration, similar to the International Space Station, but on another world. The countdown has begun. Artemis II is more than just a mission. It's the moment humanity turns its gaze outward again. With advanced technology, a diverse crew, and global partnerships, this mission marks the start of a new space age. The rockets are built, the spacecraft is ready, the crew is trained, the moon is calling once again, and this time, we're going to stay. If you enjoyed this journey through the terrifying beauty of space, make sure to like this video, subscribe to the channel, and turn on the notification bell so you don't miss what's coming next.